Hi, now let's take a look at question 36. Over here we have a diagram and the question tells us that when the switch in the circuit was closed, magnet Q was observed to have moved a distance of y cm from position R to position S. So for part A, we are required to explain the above observation. So let's begin with the electrical circuit. What happens when the switch is closed? Is there going to be a closed or open circuit? It will be a closed circuit. So this means that electric current is able to flow through the wires around the iron core, causing the iron core to be magnetized and become an electromagnet. Now when an electromagnet was placed near magnet Q, we observe that magnet Q moves away from the electromagnet. So when two magnets are moving away from each other, is there attraction or repulsion? There is repulsion. And how are they able to repel? Are the like poles or unlike poles of the two magnets facing each other? The like poles of the electromagnet and magnet Q must be facing each other, causing them to move away from each other. As such, magnet Q will then move from position R to position S. So that's the answer for part A. We first explained that when the switch is closed, there is a closed circuit. Thus, electric current is able to pass through the wires around the iron rod, causing the iron rod to become an electromagnet. What happens after that? The like poles of the electromagnet and magnet Q are facing each other, causing them to repel and pushing magnet Q from position R to position S. For part B, we need to suggest one change to be made to the circuit above such that distance y can be increased. So if the distance between the two magnets is greater, is there a greater or weaker magnetic force of repulsion between them? If the distance between them is greater, this means that there is a greater magnetic force of repulsion between the two objects, causing them to move further away from each other. Since we can only make changes to the circuit, this means that if I want the electromagnet to exert a greater magnetic force of repulsion, I need to increase the magnetic strength of the electromagnet. So students have learned two different methods to increase the strength of an electromagnet. The first method is to increase the number of batteries in the circuit, and the second method is to increase the number of coils around the iron rod. So that's our answer for part B. We either increase the number of batteries in the circuit or we increase the number of coils around the iron rod to increase the magnetic strength of the electromagnet. For part C, the experiment was repeated 3 times before the average distance moved by magnet Q was calculated and recorded, and we need to give a reason for this. So when we repeat an experiment multiple times, what are we actually looking out for? We're actually making sure that the results are not too different, and in fact, we are looking for consistent results. So why are we looking for consistency? That is because we want reliability in our results. As such, by repeating the experiment multiple times and taking the average, we actually ensure that the results recorded are reliable. So this is the answer for part C. Repeating the experiment 3 times and taking the average distance moved by Q ensures that the results of the experiment is reliable.
Thank you for watching, and I hope you enjoyed this video. If you found this video useful, do give us a thumbs up. If you want to check out the other videos we have made, do click on the links on the right hand side. Last but not least, don't forget to subscribe to our channel for more interesting videos. I'll see you next time. Bye bye!